Okay, so what we're talking about now is transformations. And the reason we want to do, want to find the best transformation because we want to find one that results in the best linear model. And the reason we want that is we want to be able to take data that is not linear and linearize it so we can actually then do fit it to a least squares regression. Okay, so when we do that, what we need to do with each transformation is firstly do a residual plot. This evaluates the linearity and tells us whether it's linear. Once we've got that, we might have two or three, if we've got two or three transformations we need to do. If out of three, two of them are linear, we look at the R squared, whichever gives us the bit higher value indicates a better fit. Okay. So in this one, we've got GNP versus life expectancy. So life expectancy, self-explanatory. GNP is a gross national product, and so that's essentially how much the country earns, to sort of put it fairly basically there. But when we're looking at IV and DV, what that means is our IV is our life expectancy. I'm just going to write that for LE for short, and DV is the GNP. So basically, to understand where the GNP is coming from, we've got to look at life expectancy in this case. So what we're going to do is we're going to plot the values of y against x and decide if the relationship is linear or nonlinear, and find the coefficient of determination. So I've actually put the data in already into the calculator. I then plotted it. That's the plot I get. Let's do a residual. So I'm going to go menu, analyze, residuals, show residual plot. And from that, we can see there's a clear pattern down here. So what we can say for that, therefore, is that it's nonlinear. And I mean, we can actually see that by eye. It's clearly a nonlinear graph. All right. And just for sake of time at the moment, what I'm showing here is the R and the R squared values that we'd get. And we can see that the R value here is 0.65. So our R equals 0.605. That's an O. Our R squared equals 0.367, which if we want to write as a percentage, we go 36.7. And therefore, here we're going to go nonlinear. Okay, so it's nonlinear. We want to do a transformation. To do a transformation, we use this thing called the circle of transformations. And depending on how your data looks, you pick a particular quadrant. In this case, our data fits in with this one here, this quadrant here. So we're going to do a log y, a 1 over y, and an x squared. Okay, those are the transformations we're going to do. If yours happened to be in this one, these are the ones you'd pick, etc., etc. All right, so what does that actually mean? I've put this in the table. Good way to illustrate it. This is our original plot. That's the plot we've got here. We're going to have log E versus log GNP. Remember, that's X and that's Y. The visual description is nonlinear. We've got our R and R squared, clear pattern in the residuals, and that's our regression equation, which we've got here. Okay, so what do we do next? We need to actually calculate these values. So for our log GNP, so that would be what I've classed as log Y here. So I'm going to go equals log here, and then I'm going to go open brackets. I'm going to put the variance. So what I'm looking for here is GNP. So that's GNP. I'm going to close the brackets, press enter, and there's my values. Let's look at the next one. We're going to go equals. In this case, we want to do inverse. What does inverse mean? Inverse, let's just put it here for a sec. Inverse means 1 over. In this case, so it's going to be 1 over GNP. Okay, that's what we're talking about. Okay, so what we're going to put here is we're going to go 1 divided by, again, we want to set the variable, and the variable is going to be GNP, and we're going to go enter. There's our values again. And the last one we want to pick is x squared. So that was life expectancy. So we're going to go equals, and then we're going to go life expectancy. So we're going to go variable life expectancy, and then we're going to square it and go enter. All right. So you can see that we're squaring those numbers. All right. So what's the next thing we need to do? We need to have a look at the plot. So let's do the first one. We're going to do life expectancy. So that's where we pick, that still stays there. It's because I haven't changed that transformation. So anytime where I've got life expectancy, it's always going to be on the X. Anything I do with the GNP, whether it's a log, an inverse, whatever it happens to be, it's always on the Y. So because I've changed the GNP, so I'm going to go GNP, and this from, I call this one log Y. All right. And we can see that we get a change in our plot, and it looks linear. So I'm going to class that as linear. Okay. Now we need to do. Let's skip to the residuals for a moment, and we can see that the residuals here are sort of showing that it's pretty much it's pretty random. It's the way it's got here. So we're going to go here, and I think we're going to zoom in. If I can work out how to zoom in on this here. Let's skip that part for the moment, and I'll work that out and show you later. Okay, I'll change that variable there maybe. No, let's skip that. It looks, it's not going above, it's not forming a pattern. So there's no clear pattern. So we're going to write no pattern there. Okay. Then what I'm going to do now is I'm going to go Control I, and I want to add calculator. Okay. Then I'm going to click variable. I'm going to go stat results, and what that will get up is, I'll go enter, and that'll give me my R and R squared. So my R here is 0.81, and my R squared will be 67%, 67.0%. Okay, let's go back to the, here my line of best fit, here my regression will be Y equals 0.456 plus 0.0456 x. Okay, let's do the next one. In this case, it's still this one, so I'm going to go 1 over. So that's my inverse y. Could have picked the right one. Inverse y. Again, that's looking reasonably linear there. So I'm going to say linear by I. Residual, there's no pattern. My regression equation is y equals, I'm going to move it so I can see it, read it better, 0.0080 plus 0. No, it's minus, sorry. It's a bit hard to see that little bit of writing. Minus, and that makes sense because it's a minus gradient, 0.000109 x. Okay, and then again we do Control I, add calculator, variable, stat results, enter. We get an R of negative 0.72 and an R squared of 51.5%. 51.5%. Okay, let's look at we're looking at the x squared one now. So we need to convert that one back to GNP. We need to take this one and go x squared. And we look at the data there, and by I, that's not linear. Okay, that's not linear. We'll come back to the R. There's a pattern. Okay, our formula is y equals negative 5836 plus 2.67x. Okay. So, hang on, and then I'll do a control I, add calc, variable, scroll down to stat results, go enter, and that's going to give me R of 0.62 and an R squared of 38.4%. Okay, so what is best transformation? Well, clearly it's not this one, so I'm going to cross that. Okay, it comes down to these two. All right, and clearly the one where I've got the best R squared, let's pick a different color while we're here. One of the best R squared, because these two are linear, it would be this one. So it's going to be the log of the GNP. Okay. So the way we'd write it, so we need to take this and write it appropriately. So what we're going to have log GNP equals 0.456 plus, oh, did I write that down wrong? Let me quickly double check that. That was life expectancy. That was log Y. No, that's correct. That's good idea to double check sometimes. 0.0456 times, in this case, it's life expectancy times LE. So that's the equation, how you need to write it. Okay? So the line of best fit can be used to predict the life expectancy against a country's GNP. Use a transformed regression equation to calculate the predicted values. Oh yes, this is very important, this part. Okay, I've actually done this here. This is the point you need to change. Okay, remember we had it as y above. Whatever the y one the transformed version you've got, you put that in. So in this case, it's log of GNP. So anytime you put a GNP value into this equation, you have to log it. If it said 1 on x, this one would be 1 on x. All right. So what we do now is we're going to calculate our values. Okay. And so the idea you do here is you find out the actual life expectancy. So that's where you'd look up our actual life expectancy value. So for GNP, our life expectancy is 58. Okay. For predicted life expectancy, so I'm going to do the first one, and then I'd expect you to finish them off, just so to save on time. For predicted life expectancy, what we're going to do is our GNP is 950, so we're going to type log 950 equals 0.456 plus 0.0456 times LE. Okay. And again, You can do this on the calculator, and you can do it as a solve function. So you can write equals solve log 950 equals 0.456 plus 0.0456 times LE. No, hang on, because you've got to go comma LE. Okay, so we can go back and and you do this for each of those ones, and that'll give you your residual. So your residual is going to be, that's going to be equal to 58 minus whatever I get in this value here. So let's go back to home screen. We're going to calculate, and we're going to calculate for this. We're going to go solve okay, and we're going to go bracket, we're going to go log 950 equals 0.456 plus 0.0456 times, this is where we're going to type in LE, and then we'll do our comma. If I can find where the comma is, there, and we go LE, close the brackets, and we get a value of 21.928. Okay. Right, so we get a life expectancy of, in this case, LE. Oh, that looks a bit wrong. I think we might come back to that one. Okay, but you understand how to do the rest of it, and we'll come back to this in a moment. Okay. Okay. So what I just realized, and this is just something to be careful with, you should have base 10. So when you do your calculation up here, when you got that base 10, so you go control, and then so you got the log, you're going to put 10 down there. Then up here, you want to put 950 because that's what we had before. And then you go enter, and that'll give you a life expectancy of, equals 55.301. Okay, so that means that's what's going to 55.301. So that means that's going to be 55.301. And so we're going to go 58 minus, we just need to get rid of these bits. We go enter. So our residual is equal to 2.7. Okay, that's what our residual will be for there. And you can do that for each of these subsequently. I'm not going to do it because it'll take too much time, and this has gone on long enough as it is, I think. Okay. All right. So hopefully that helps you work through any concerns, any issues you've got with this particular topic. And that's all for today. Thank you. Bye.